Hello guys and welcome back to the SimpliCode programming channel. This is Vikesh and let's get started with today's topic, which is stacks in Java. Now if you remember, when we were covering about the collections framework, I walked through a complete hierarchy of interfaces, abstract classes and concrete classes, and I briefly talked about what are stacks and what kind of functionality they provide, in which scenarios you would use them. So let's do a quick refresher of what stacks are and why do you need them. So stack is basically a kind of list, we can say. Technically a list, but it's not exactly a list. So never say that stack is a list. It's just because it is extending the list interface. That is why you can say it is a type of list. But actually it's not a type of list. It has its own representation. You will use stack in the cases where you will have to maintain a Lifo representation of the objects. Now, what is a Lifo representation? It means last in, first out. That's basically the full form of the Lifo acronym. And what it means that the element which goes at the last inside the collection will be the first to come out. Think of it as a stack of plates at your dining table, where you put plates over one another, and the last plate which you put on that plate stack will be the first one to be picked up by somebody who wants to eat something, because people will not take out the bottommost plate, otherwise the whole stack will fall. That's why they will take the topmost plate, and that's why we call that plate representation as stack of plates. And this representation in Java is exactly inspired from that, and we call this stack. You see a bracket here, you see a generics representation here, which says E, which means that stack, you need to define what kind of stack it will be, whether it will be a stack holding integer values or string values or any of your custom class values. So that is the basic property, that the last element to be going inside the collection will be the first element to be coming out. So let's have a look at an example of how you can use stack and what are the different properties which we can leverage while working with stacks. So for that, let me switch back to Eclipse. And you can see I have a class created here, which is called stack demo. And it has a public static void main method, which is making this particular class executable. And here you can see I have initialized the stack. So stack of the class type. So you provide the class type as string, which means that this particular stack is going to store string objects. And then you just say new stack and you provide the same generics here. Actually, you can skip that. If you do this as well, this is going to work fine. So that is how you can basically initialize a stack. You can see the import here, which you need to import to make this work. It's basically part of the java.util package. What are packages? Again, we will cover that in detail when we'll cover classes and constructors and etc. So now at line 11, I'm using a method called push. Now the push method is used to insert elements inside the stack. But we call it push because, like I said, stack is a special type of collection. That's why it doesn't use the add method. Rather, it has a method which is called push, which is used for inserting elements or pushing elements on the top of the stack. So at line 11, you say stack.push. Basically, this stack is holding the list of all the countries or the entries of all the countries. So you say America at line 11. Then at line 12, I'm again doing stack.push and entering Germany. At line 13, I'm again doing another stack.push and entering India. So basically, I have added 3 countries' names inside this stack. Now, if you can think about the mental representation, or if you try to build a mental representation of this, then stack.push America is basically the first entry. Then when you added Germany, this entry went on top of America because that's how the stack of plates work, right? And then India entry will come on top of Germany. So the America is the bottommost entry. Then we have the Germany, which is sitting in the middle. And then at the top, we will have the entry for the India string. And after that, at line 15, I'm just printing the stack. So If you want to just observe the output till 15, let's comment this particular section for now, and we will just focus till line 15. And once we have figured that out, then we will move to the rest of the code here. So let's run this particular program and observe the output. So you can see this is the system.out.println, which is getting printed. So I'm printing a stack string, and then I'm printing the stack as is. And you can see it's printed in the sequence in which the elements were inserted. So when you print the stack, you will not be able to figure out which is the bottom and which is the top, because you don't need to know that while you are just printing the whole stack. When you actually want to understand and observe that behavior is when you will start taking elements out of the stack. At that time, it would be critical to know which element is at the top and which element is at the bottom. But for now, we can see that we are able to successfully add elements or push elements to a stack, and we are able to successfully print the stack. Now let's uncomment this particular code and understand what is happening here. So at line 17, I'm using another method of the stack, which is called pop. So the push method was used to push elements or insert elements into the stack, and the pop method is used to take elements out of the stack. And remember the Lifo property of the stack, which means that if I call the pop method, which is basically I'm telling stack to remove an element, it is going to remove the topmost element from the stack. And it is also going to return the element. Remember that part? If you want to remove the element and if you want to see which was the topmost element which got removed, then you can actually store the output of this particular execution into a variable, and you can see which element was popped or removed. And that's the basic property of a Lifo, right? That when you have a Lifo collection, when you pop the element, when you call the pop method on the stack, you would expect the topmost element to be coming out. And that's why we store that into this particular string, and then we print that popped element to verify and see which element was actually popped. And after that, because I have removed one element here, then I print the modified stack to just see what all is remained in the stack. So let's run this particular program. Now let's comment the first part. Maybe this particular sysout is not needed because we have already observed the output of this. So let's observe these two output after pop, which was the element which was popped, and how the stack looks like after the removal or popping of one element from the stack. So I right click run as Java application, and now if you remember, when we inserted the elements, we inserted the elements in this fashion: America, Germany, and India. And when I called pop, the topmost element of the stack should get removed. So basically the Java looked at this particular stack, and it could see that the element India was added at the very last, which means this element was sitting on the top of the stack. And when you called stack.pop, this method or this string basically got popped out. This element got removed from the stack, and we stored that element into this particular variable. We printed that element, and here you can see that output that the popped element is actually India, because India string was at the top of the stack in this particular case. At line 20, now I'm printing the modified stack, basically printing what is remaining inside the stack after we called this pop. And we can see that the string India is gone from the stack, and now Germany is the new top. If I call this again, let's call this again to verify if Germany is at the top actually. So I'm calling the stack.pop again. Let's just call it popped element 1 for simplicity. Don't do that in production code. Always give nice variable names. But for the sake of demo, we can do this. So let's see what happens if after we have these two elements left in the stack, and if I call pop again, which element gets popped. So I right click, run as Java application, and we can see that this was the representation here at line 20. Then I called pop, and the popped element was Germany, because now this Germany was the new top. And after Germany has been removed from this particular stack, then this stack has only one element, which is America. So this is how you can work with the stack, and these are the most two popular methods which are push and pop, which you would basically require to use in your program if you're working with Stack. And let's say you have a scenario where you just want to view which element is at the top. You don't want to remove it because pop is also going to remove the element, right? So if you don't want to remove it, but just want to view which element is sitting at the very top of the stack, then you can call the peek method. So this peek method is basically going to return the topmost element, but it is not going to remove the element from the stack. So let me just verify that as well for you. Control C, and after we do the peek, I'm going to print the element again. Let me just call it as peeked, or let's say just call it as top element, and then we print the stack again. So let me just comment out this one as well, and now we'll run the full program. Let me call this as original stack. So we'll first print the original stack, then we'll remove one element and we'll print that element, and we print the modified stack. Then I call the peek method, and then again I print the stack to see if peek also removed the top element or it just returned the top element. So let's run as Java application and observe the output. So the original stack was this, where India was the topmost element and Germany was in the middle and America was at the bottom of this particular stack. And then we popped the top element, which was India, and then the stack got modified and we had only two elements left into it. Then here we called peek at line 22, and we just at line 23 we printed the peeked element or the top element. So in this particular stack, if we call peek, we got Germany. But if we printed the stack again, we can see that Germany is still there because peek just returned the top element, but it did not remove the top element, whereas pop will remove the top element and also will return that element to you if you want to store it. So that's all I wanted to cover in this particular session, where we talked in depth about the stack features. And like I always say, please also go to the Javadoc API and read about all other methods and functionalities which are provided by the Stack collection. In the next session, we are going to focus on queues, and we'll look at a hands-on demo of queues as well. If you like this video, a thumbs up would be massively appreciated. And please don't forget to subscribe to SimpliCode for more programming related videos. Thank you, and we'll meet again in the next session.